Okay, let's dive into this. If you work in tech, or honestly, even if you just use a banking app or scroll through social media, you are interacting with the direct results of software testing every single day. But today, we're going to completely reframe everything you thought you knew about quality assurance. We're breaking down the true anatomy of software testing to see what really makes it tick, using our source material to give us a hard, undeniable look at how quality is actually built.
So, let's start right off the bat with this question. Is software testing just about finding bugs? I mean, it's a super common assumption, right? The traditional mindset is basically that developers write the code, they toss it over the fence to a tester, and that tester's only job is to poke around and try to break the whole shebang. But treating testing as just a simple bug hunt, that is a massive myth, and it severely limits our understanding of the tech ecosystem. So today, we're exploring the reality of what testing actually is, why it's absolutely crucial, and how it shapes the digital tools we rely on.
Right, let's get into Section 1, Decoding Software Testing. We need to start by breaking down the exact anatomy of this core concept.
The literal definition is that software testing is the process of evaluating and verifying that a software application or system meets specified requirements and works as intended. Now, let's look past the surface of that. The absolute crucial words here are evaluating and verifying. Testing isn't about guessing. It's definitely not about blindly clicking buttons to see if a program crashes. It's a highly systematic, analytical process. You're actively measuring the software against a very specific, predefined set of requirements. It's like establishing a baseline of truth to make sure the system behaves exactly the way its architects and engineers originally intended it to, way before it ever reaches the public.
So, how does that textbook definition translate into practice? Well, it breaks down into specific actionable steps that really build in complexity. First, at the most basic level, you execute the software to identify defects. That's kind of the baseline of the job. Second, you elevate that by ensuring the system is free from critical bugs. I'm talking about those massive, show-stopping errors that would just completely ruin the user experience, or, worse, compromise data. But the third point, that's where the true depth lies, confirming delivery of expected business value. Think about it. You could have a completely bug-free application, but if it fails to generate revenue or actually solve the user's problem, well, it's still a failed piece of software. Testing bridges that vital gap between just running lines of code and achieving real-world business goals.
Moving on to Section 2, Verification versus Validation. To really understand testing, we have to dissect its dual core goals. Verification and validation represent the two sides of the quality assurance coin. They're literally the twin pillars of any successful QA strategy. And while they might sound incredibly similar in casual conversation, in the world of software engineering, they ask completely different but equally vital questions about the product being built.
Now, what's really interesting about this slide is the specific distinction it makes. Think of it like building a house. Verification asks the engineers, did we build the house exactly to the architectural blueprints? It's a completely inward-looking question, right? Checking if the product was built correctly according to the internal specs. Validation, on the flip side, asks the homeowner, is this house actually comfortable to live in? It looks totally outward, asking if we built the right product for the market. You could verify a house perfectly, so every measurement matches the design specs without a single technical error. But if that perfectly designed house has no doors, it fails validation entirely. For true software quality, both of these goals absolutely must be pursued rigorously.
Which brings us to Section 3, Beyond Finding Bugs. It's time for a major paradigm shift regarding what testing is actually meant to accomplish.
Preventing defects and improving quality. This right here is the true endgame of modern quality assurance. Software testing isn't solely a reactive hunt for defects that have already slipped into the final code. Instead, it's an active, continuous improvement mechanism designed to elevate the overall quality of the product throughout the entire development lifecycle. This involves catching fundamental logic errors in the planning phase, meaning those bugs are literally never coded in the first place. Testing acts as a proactive shield, not just a safety net at the very end.
This comparison really breaks it down side by side. The traditional reactive assumption, it essentially plays a game of whack-a-mole with software errors after the damage is already done. It treats testing as a cleanup crew. The proactive reality, however, completely shifts the engineering culture. It focuses on preventing defects from happening in the first place and improving overall quality from the ground up. It brilliantly shows the vital transition from simply detecting what went wrong to actively engineering and ensuring what goes right. Doing this saves time, it saves money, and for sure, it creates a vastly superior product. So, I'll leave you with this. If your testing only finds defects, what are you actually doing to prevent them?
It's a provocative thought, isn't it? If your entire approach relies strictly on catching mistakes after they've already been coded, you're completely missing out on the true power and business value of quality assurance. Shift your mindset. Look beyond the basic bug hunt. Balance your internal verification with your outward customer validation, and start proactively engineering quality right from day one.